Okay, I welcome all of our participants in the third NaDiMa Dialogue. Very welcome to this event. My name is Mohammad Farzanegan. I am from University of Marburg, from Center of Near Middle East Studies and the Economics of Middle East Research Group. So together with us, our colleagues from Iran and Germany, in Iran, the NaDiMa project that we started this year, supported by the German Academic Service and also the AMT, Federal Foreign Office in Germany, within the program of Higher Education Dialogue with Muslim World. So in Iran, we are collaborating with the University of Tehran, Islamic Azad University, and in Germany, we are collaborating with University of Freiburg. This is an interdisciplinary project and exchange, academic exchange, which aims to review different aspects related to the natural disaster management in Germany and in Iran. And we are very happy that up to now we have managed the first two dialogues successfully. The materials and documentation are online on our website. Today we have the third event on the dust problem and drought. And we will continue in future the other dialogues on the issues such as flood management. Hopefully on the corona we would have another dialogue, and two other dialogues that we explain it later on. I stop here and I would like to invite my colleague Dr. Nazari from Faculty of Natural Resources, University of Tehran, who is moderating this session, to also introduce the other speakers and agenda of today's event that we continue from now on. So Dr. Nazari, the floor is yours.
Yes, thank you so much for from Professor Farzanegan, and I would like to say hello to all participants and the esteemed presenters. It's a great pleasure for me to be as a moderator of these sessions. As you may know, this session is about drought, sand and dust storms, its challenges and management. This is the third sessions on the webinars on these projects, NaDiMa. Professor Farzanegan spoke this project and gave a brief information about these projects. But these sessions is focused on the natural disaster, mostly in dryland environments. You know that the dryland environments are very different from other lands in the earth, and over the past decades, because of developing in this country, because the most of the drylands and the countries in drylands are in developing countries, and so over the past decades, developing is more. The rate of developing in this area is more than the other area. For example, in North Africa, MENA, and Middle East, in Central Asia, and so the natural hazards can influence the welfare of the inhabitants, of the peoples in these regions. And most of these hazards are the geomorphic hazards, such as mostly aeolian processes and droughts, land degradation, desertification. So these sessions was organized to consist these topics. In these sessions, if I want to say a brief program of these sessions, we would have three presenters, and here I would like to thank all of them. to accept and lecture in these sessions. The first topic is about dust and sandstorms, and the first presenter is the Professor Ope. Professor Ope, he is the professor at the Physical Geography and head of the working group of Hydrology and Hydrogeography and Soil Geography at the University of Marburg in Germany. He is working on hydrology and dust storm and dust deposits monitoring, especially its effect on the water bodies and the aquatic ecosystems, and also he is very familiar with Iran conditions and some other places in drylands. He has several travel to Iran, and he knows the situation in Iran very much. And the second presenter would be Dr. Abbasi. He is the scientific member of Desert Divisions of the Research Institute of Forest and Rangelands in Iran. He also had several mega projects on aeolian processes and sand and dust erosion, sourcing, and management of them for 15 minutes. And the last presenter would be Dr. Malekian. He's the member of the faculty of scientific member of Faculty of Natural Resources, University of Tehran. He is also the member of several scientific associations, national and international, and collaborate as advisors for several parts, especially technology part, scientific and technology part of the University of Tehran and international affairs office. And for participants, the first presenters would be the Professor Ope, after that Dr. Abbasi, and finally Dr. Malekian, as I said. But for presenters, I would be pleased if they could write their questions during their presentations. Each presentation in a general chat room, and the NaDiMa colleagues will get together them, and at the end of the presentations, we would have questions and assessments, and we will gather their feedbacks for the next sessions and to give the better qualification. First, I would like to invite Professor Christian Ope. It's a great pleasure for me to invite you, Professor Ope, to give your presentations. Thank you so much.
Thank you. So first of all, hello from me to all the participants, and a special thank you to Mohammad Farzanegan for the organization of this special event. For me personally, this is the first online meeting. I'm already a retired person when Corona came to Germany, and so far I had no training before. This is the first official online presentation. Due to the fact that I am the first speaker, I decided to inform you first about some basics of dust and sandstorms. Of course, dust and sandstorms is a very important issue, is a very important natural disaster. So first I will show you some basics from the research history, and I will use for these basics also examples which we have done in my working group, with a special thank to my former colleague Michael Kroll, together in Central Asia, in Kazakhstan, Uzbekistan, and Turkmenistan. And I will also show you some examples from Australia, Germany, China, and other regions. And I use the same examples to show also different effects of sand and dust storms. Due to the fact that I am not an economist, so I have already only prepared 2 slides regarding economic impacts, but you will see that there's a very important fact speaking about economic impacts of sand and dust storms. And at last of my presentation, I will try to give some recommendations regarding mitigation and hazard reduction, starting with some basics. So, of course, for sand and dust storms, one very important prerequisite is wind. So wind we can understand as air masses transport as part of the atmospheric circulation from a high to a low. And the very important fact of the so-called Aeolian transport system, that means the transport system by wind, is the sub-processes of deflation or erosion of particles, mostly from surfaces, the transport and the deposition or the sedimentation of particles. Independence on the size and the weight of the particles and independence on the wind speed, they are differently able to be transported by the wind. Here is another such slide and a few words about such basics. So it is very important to differentiate between sand transport and dust transport. So the sand transport is mostly a short distance transport, and it consists predominantly of coarse, mostly sandy particles. The dust transport is a long distance transport by wind, and the different moving by the different sized particles you see a little bit in the figure below. So there's a moving, it's called creeping, near to the surface by the wind. There's a moving of particles, we can translate it also as a kind of jumping from the surface, but also near to the surface. But the finer particles are suspended in the air. And it is also important to mark that the finer particles can remain in the atmosphere up to several weeks, while the larger particles, which are creeping and under saltation, falling down very shortly again, and also the larger particles, which can be partly suspended in the air, which are larger than 70 microns, they will be deposited in less than 1 day. So the particles, where they come from? They come from surfaces, mostly from land or terrestrial surfaces. And what are the features? So these surfaces, where they come from, are areas of deflation or wind erosion, and where they are deposited are areas of deposition or sedimentation of sand and dust storms. And the following features, which you see in the lower part of this slide, are supporting this deflation or wind erosion transport of loose particles. So these are especially large wind open areas as we meet near coasts, near lakes, near treeless areas, or large open pit mines. Also droughts or dryness or a very low soil moisture content in the upper soil and sediment layers is another prerequisite to transport loose particles by the wind. But also a low degree of biological crust, a low degree of vegetation in general are other prerequisites, and also such things like the loosening of soil particles, overcome the cohesion forces of agricultural used land by tillage or trampling can be another prerequisite for the wind transport. But such particles are not only from terrestrial ecosystems, they can also come from limnic ecosystem, and the most well-known example is the Aral Sea. So the Aral Sea was a former sink of river sediments from the Amu Darya and Sur Darya, and now it became a source of fine sediments, mostly a source of salts. And here you see another example from this study area, which we have analyzed for long years. In the satellite images below, you see left-hand side such westwards winds, right-hand side such eastward winds from the dry bottom of the Aral Sea, and in the upper part of the slide you see how it looks like in the terrestrial ecosystems. Also, this is a last example from the Aral Sea. In the upper part of these maps, you see the detection of dust storms, which was increasing between 2005 and 2008. And in combination with the increasing dust storms, we also could detect, or the Kazakh colleagues, Bayeva and Vitovskaya, detected the increasing deflation areas of this study area. So we can summarize a low sparse grassland, barren ground, different deserts, playas, sparse dunes are one prerequisite, and the other prerequisite are low precipitation periods and areas, and a strong wind. But additionally to these prerequisites, also volcanic ashes, sediments from dry lakes, sediments from glacial or periglacial sediments, forest and grass fires, sediments from marine terraces and sea spray can contribute to dust in the atmosphere, and also human activities like the burning of fossil fuels, the alteration of surface coverage, industrial activities, slashed and burned agricultural areas, overgrazed grasslands or open pit mines can contribute to the dust in the air. Some illustration of some examples you see here in this field. I think this is more or less clear. We can keep on. And this map of is a simple map of global dust source areas and the main transport trajectories. And you see this map, you see the main sources are in the arid and semi-arid climate, mostly located in the northern and southern tropics, the Tropic of Cancer and the Tropic of Capricorn. These are the main source areas. Another global example is this map from Schall, which you can see in red columns, the main source areas on Earth, in black again the transport trajectories, and in blue then the main deposition areas. And again some examples from this global map. You can see here the so-called Asian dust transport from inner Asia, mostly from China, via the Pacific Ocean to America, or the Australian dust transport. Very large example of this Australian dust we had observed in September 2009. The dust came from inner Australia, from the red center of the continent, but was transported to the east coast and again further on to the Pacific. Now I come to some effects of sand and dust storms, and one very important effect is that dust particles are so long remaining in the atmosphere. Therefore, they have a very big influence to the climate and to the atmosphere. So dust in the atmosphere caused a heating in the atmosphere. It leads to an increase of solar energy absorbed in the atmosphere. But at the same time, where you have dust in the atmosphere, you find a cooling on the surface. You will see it on examples also in the ocean. The effect to cloud formation is quite differently discussed. Some expect increasing precipitation, some lower precipitation. This is still in work. But very clear is, of course, the effect on the visibility, of course, where you have a lot of dust in the air, also near the surface. We also have observed the lower visibility. And this not only near the surface, but also in the higher layers of the atmosphere can affect the air transport. And especially, again, back to the Earth's surface, it especially affects a lot of health problems. First, some example to the effect on the ocean. You see here again in this upper part of the satellite image, the Saharan air layer transported dust from West Africa via the Canary Islands to the Caribbean Sea or to Latin America at all. And in the lower part, you see the aerosol index above the Atlantic Ocean. In red, stronger or more dust particles, in yellow, less. And you see also sections without red and yellow particles, and these are the only sections where tropical dust storms can origin, because they are not so cool So tropical dust storms, you might know, need a surface ocean temperature of 28 centigrades. This temperature was lowering by the areas which are covered by dust in the atmosphere. Therefore, tropical dust storms only can origin where you have not so much dust in the atmosphere. This you can see also in these two figures from 2005 and 2006. Some of us will remember that 2005 was a very important year where New Orleans was affected by very strong hurricanes, but also the years 2008 and 2017 were such hurricane years with no or only a less part of dust in the air. But the following year, 2006, was a year with a high amount of dust in the atmosphere above the Atlantic. Therefore, we had not so much hurricanes. This feature or this combination between the surface temperature and the hurricane origin you can see also in a longer data road here below. And this is not only the origin of hurricanes, the dust, when it will be deposited near the ocean or near the coast, affects also the marine ecosystems. It causes a bleaching or declining of coral reefs, as you can see in these slides or in these photographs. And in some cases, this might cause a mass mortalities of other marine species. But dust following to Latin America has not only such negative effect, we know also the positive effect of fertilizing the ocean at all, but also fertilizing the tropical rainforest, for instance, the Amazon rainforest, which are poor in fertilizers, and we get more fertilizers because dust is not only a simple dust particle, it is a composition of different minerals which can function as fertilizers. I come now to a fully other effect of sand and dust storms. You know it even when you are from Iran better as I. But here I have examples from other areas of the world. So we know such sand and dust transport also from our dunes. So Chara sands in Siberia, Kyzyl-Kum, a desert in Uzbekistan, Taklamakan, famous desert in West China, and also Germany has a very large dune, but this dune's origin is from the Pleistocene especially. So aeolian landforms like dunes function as sinks for sand especially, but the fact that we do not find so much dust on the surface of these dunes is connected with the reason that the dust was already blown away. Another example is the typical degradation of land ecosystems by sand and dust storms on the deflation areas, on the source areas. Typical yardons, as you see this from China, or also the deflation of the dusty surface layers, which bring the lower part salty layers to the surface, which you can see in these photographs from Uzbekistan, are such effects on the deflation or source areas. But also on the deposition areas, we have different effects of sand and dust storms. You see in the pictures that they cover traffic lanes, they cover partly houses, of course they cover vegetation, leaves or stomata. This combination of disturbances of these organisms, and you see again the visibility, the reduced visibility, and also as an example of the dry riverbed of the Amudaryan in Uzbekistan, which function also as such source, but at the same time also deposition area. What you probably do not know is that also in Germany we had, due to the climate change, dust storms. So, and I was lucky to be in such accident, but I have survived. This was very lucky, and I could realize these photographs. So during this dust storm from April 2011, unfortunately 8 people died, 48 people injured, and approximately 150 cars were damaged in this mass accident. This was connected with a very long dry winter and spring period and very large fields which were not covered by vegetation during that time, and we had strong winds from the Baltic Sea. So this was the main, shortly speaking, reasons for this very big damage. More famous are the dust and sandstorms in the dry areas of North and Western China, as you can see in these maps. Although in the past 50 years of the 20th century, the number of annual dust storm days in China were decreasing, but since 1997 there's an increasing trend. And I will show you from Shang, from China, scientists, some examples which he gave me here, which sand has damaged a fast train Urumqi-Beijing in April 2006. And a little bit later, also in April 2006, Beijing was affected, the capital of China was affected by heavy dust storms, which you can see in these slides from Beijing and also in these slides from Beijing. So China is famous for these features. Back to my more investigated study area in Central Asia, in Uzbekistan, Kazakhstan and Turkmenistan, I can show you also one example for the effect of sand and salty dust storms on human health. So in the table left below, you see that children were tested, and approximately 11% of the tested children were affected by acute pneumonia, chronic pneumonia and chronic bronchitis due to the large number of salty dust storms in these areas. And right-hand side in the table from Uzbekistan, in a special part of the Karakalpakstan in Uzbekistan, you see the increasing number of cancer. But we must consider that this part is not only an effect of sand and dust storms, this might be also an effect of too salty drinking water. In the two following figures I took from source the UNEP, VMO and UNCCD report about global assessment of sand and dust storms. This table where you can read about immediate term and long-term effects. I don't want to read now all these things, but particularly we have touched these examples, most of these examples by the effects, and you can imagine when you want to repair this or when you want to prevent this, not in all cases it is possible to prevent, but we should try to reduce the effects, and these are very high costs are needed. In the following table, some single authors have published in the same report of the UNEP and VMO and UNCCD some numbers. Also, these costs per cubic meter removal of blown sand seems to be relatively low. When you look in the text below the table, you find some examples of very high costs, partly differentiated between off-site costs and on-site costs of wind erosion, but also some costs in Iran, in Iraq per year in US dollar, and also Australia has published some costs, especially to try to repair the health effects, and you can imagine which amount of costs are needed to prevent or to repair or to reduce the effects. So at last, in the last part, I will try to show you some consequences. What can we do? In one of the first figures when I spoke about the basics, I showed you already these words showing the following surface features which support deflation processes. Not of all we have a big influence, but we have influence to increase the coverage of vegetation. So a higher degree of vegetation is always good, as well as in the source areas, as well as in the deposition areas. And also we have influence, we have managing influence on the increasing sorption forces and the increasing stabilization forces to soil surface. You see such examples in the photographs below, plantations in Khorasan in our study area, which contribute to an increasing coverage of vegetation, and this vegetation now functions also as a sand and dust catcher in the deposition area. Right-hand side also sand and dust catcher from Uzbekistan with the same effect. And the next slide you see also on the dry bottom of the Aral Sea, people from Uzbekistan tried to grow haloxylon to prevent the deflation forces. Of course, it is very difficult to set up or to plant such plants in a very dry, waterless area. You see the example without watering that the growing height is not so good. But in this diagram, you see that with watering, it is possible that the Solanjak, the Saxal or Haloxylon survives for some years, and when it's growing the first year, then in most of the cases it can take the water from very deep layers. Also, this figure shows the analysis of the growing height, the maximum, the average, and the minimum growing height of these planted plants on the dry bottom of the Aral Sea. But in all cases, you see the lines with watering are, of course, get to higher growing heights of these plants, so they have more prevention function as in cases of without watering. Other examples you see here for the increasing absorption and stabilization forces of the soil surface, like again dune stabilization by sand catchers. These photographs I took in Iran together with Mohammad Reza Abbasi, which we'll speak a little bit later, in East Iran by plant covering for the revitalization with the help of watering, if water is available, of course, or the dune stabilization by oil mulching, common method of improving the situation, or plantation of biological barriers. Another very important management measure is to reduce the number and frequency of grazing animal in all areas of pasturing. So in this table you see that the number of pasturing animals in China grew up in the last decades of the last century. But it is necessary to reduce it because when you have such low covered surfaces, this of course might be or is a very large source area of such sand and dust storms. As a kind of take-home message, I try to summarize what I want to inform you. So I hope I could tell you that it's very important to distinguish between short-distance near-surface sandstorms and long-distance via the atmosphere dust storms. Barren ground and sites with low coverage by vegetation are the main sources of sand and dust storms. The Aeolian transport system consisting of deflation, transport and deposition we have touched. Sand transport is forming deflation relief like yardans at the source areas and dunes in the deposition areas, but in some cases the sinks can become also sources of sand and dust storms. Dust transport via the atmosphere modulates the radiation in the atmosphere, the surface temperature of the ocean and the other surfaces. They have also influence to the climate, to the snow and ice, which I had not time enough to tell you more about the last fact. Sand and dust storms and its depositions do have mostly harmful effects to infrastructure, plants, animals and human health, according to the last, especially respiratory tracts, inflammation of the eyes and others are affected. For the prevention of these effects and the reduction of the negative effects of sand and dust storms, it is necessary to increase the coverage of barren ground by vegetation or, if available, by water. And of course, if you are in a sand and dust storm, you know it when you are from Iran, it is necessary to use face mask, not only under corona conditions. So I think this is what I have prepared. Thank you very much. And yeah, I hope we have a good discussion, and I'm sure we have other good presentations. Thank you. Tashakkur.
For very pointed presentations, Professor Oak, and also again thank you for following the time. And the participants, again I should remind these points that the participants can ask their question in a general chat room, and after all of the presentations we will ask from the presenters. So here I would like to invite Dr. Mohammad Reza Abbasi from Research Institute of Forest and Rangelands, Desert Research Division. And it's great pleasure for me to invite Hamid. Hamid is a senior researcher in Desert Research Division. He as a general director of several mega projects in Iran and more than 20 research on the local parts of the Iran, especially about drought and sandstorm, about hazard mapping, sand dunes morphology, and also about land use planning, about the management of the Aulian processes to control of them. Hamid, you have 15 minutes for your presentations, and we can start. Thank you. Yes, we can see Hamid.
Oh, hello, everybody. I'm very happy that I'm here, and it is easy to speak after Professor Ope because he speaks about the basic of the Aeolian systems, and therefore I would like to focus on the sand and dust storm in Iran, challenge and management. Let me take a look at the outline. I would like to start with introductions. First of all, I will start with an introduction about the wind erosion challenge in Iran. Then I will look at the two problem statement and background in Iran. Most of my speak focus on the sand and dust storm problem sources in Iran. Especially I would like explain about two examples of the sand and dust sources in Iran, Sistan and Khuzestan, and finally I will take conclusions and summarize of my speech, and I will be glad to answer your question at the end. As you know, Iran is a let me just Iran has two topography, two main topography. It's located in the Middle East, and two main topography: Alborz Mountains and Zagros Mountains, with these directions, and two vast desert area, Dasht Kabir and Lut Desert, are located in central of Iran, and two main of elements is Persian Gulf and Oman Sea in the south of Iran, and Sistan is located in east of Iran, and Khuzestan in west of Iran, in near of the Iraq borders. As you know, 55% of Iran covers by deserts, and annual average rainfall of Iran is 228 millimeters with 70 degrees Celsius, the average of temperatures. And wind erosion, why wind erosion is important in Iran? As you know, 18-19% of Iran is under domain of the different process of the desertifications, and 35 million hectares of Iran affected by wind erosion. As you see, this is a map of the sand dunes map, a new survey of sand dune map in Iran. 4.8 million hectares of Iran covered by sand dunes, and about 193 million euro wind erosion damage every year to infrastructures of Iran. I couldn't see the next my slide, so I don't know. I hope you see the next of my slide.
Yeah.
But I didn't see. But I have a result of my
problem statement about sand dunes.
I don't know why what happened for me. I couldn't see. So let me continue. As you know, wind erosions suffer to infrastructures, produces soil losses, and reduce soil productivity, and decrease agricultural production, deteriorate soil quality, and dust storms also reduce visibility, affect human health, polluted air, and affect on the transport of the airplane, and also navigation on the ships. And shifting sand dunes damage to the infrastructures in south of Iran, also in the Khuzestan and in Sistan, fill up of the canals and road ditches, cover of the railroads, and causes of the house damages. Some and most of women usually more of the dust, and say all places are dirty by dust every year. And as you see, some damages to the historical places and fill up of the some dams in and damage to agricultural area. No, I couldn't see. As you see, this is the distribution of spatial wind energy in Iran. According to classification of wind energy in by Freibergs and Deans, when wind energy is when environment experiences PP upper of 400 vector unit, wind energy environment is high, and between 200 and 400 environment experience and intermediate conditions, and lower 200 is a low wind energy. And as you see, the variability of wind energy is high variations, and in the east of Iran, it is a high environment, wind energy environment, and as you see, Sao and et al. Provide of the sand and dust storm frequency, and as you see, Sistan and Baluchistan and Khuzestan experienced high frequency other place than other place in Iran. For controlling of the dust and sand sources, first of all, we should find of the identify of the dust sources. There are different methods of the identification dust sources. Field survey, numerical modeling, usually they use a different map, and satellite images. We start to use a mix of methods, and now this is the ongoing research we provide of the dust sources, start to find of the dust sources in Iran. It is not complete, it will be changed in futures. And also we define a national plan to sand and dust sources control. After the identify of the SDS sources, we should focus why dust sources is activated. Two main reasons of activated of the dust sources are climate change and anthropogenic causes. After that, we should find of the which kind of the forms of the dust sources. We classify dust sources into the three different shapes: point sources, linear, and area. Point sources like dry lake, saline lake, lowland, and linear dust sources is a dry river wash and a road. An area is they are very vast, like alluvial and floodplain, farmland and bare land, and each of them need of the different of strategy to control. For point source, we should focus on right to provide right waters and also realize waters from dams and vegetation rehabilitation. Rehabilitation, like Professor Op explained about this. The Sistan ephemeral lake is an example of this kind of the sources. I will be back to this. And for area, for linear, we should be do a environmental impact assessment to develop of the roads and linear projects, and also vegetation rehabilitation of for the as a windbreak around inside of the roads, and also traffic management. And for our area, we should be focused on the landscape management based on the ecological and socio-economic sources. Khuzestan does source classify into the area. As you see, this is a relationship between droughts and dusty days in Khuzestan. And as you see, if the drought index stand upper of the as a positive numbers, it means that the ecosystem experiences a normal condition. But if it find a negative numbers, it means that droughts happen. And as you see in Khuzestan, when droughts happen, the frequency of the dust increase in the last decade. I would like to start with the first of the examples. As you know, Sistan is located in east of Iran, and Helmand or Hirman River basins extended from Kabul into the Iran in Sistan plain. And Helmand River irrigated of 6 ephemeral lakes are located around of the Sistan plain: Hamune Puzak, Hamune Changesor, Baringak, Saberi, Hirman, and Godzere. Due to of the established dams, as you see, 6 dams on Hirman River, less water reached to these ephemeral lakes, and a mega drought happened in Sistan. And as you see, it experienced wet conditions and dry conditions, as you see. And as you see, it affects on the socio-economic of the regions. And when droughts happen, these ephemeral lakes play as a dust and sandstorms. We have a very strong wind, a northerly wind, which called Sadobisruze, means the wind that 120 days wind with the north to south direction. Then when it reached to the Sistan plain, it turned into the Afghanistan. And as you see, some pictures of the drought conditions. And oh, I lost again. Sorry. Yeah, and as you see, dust storms is a regional problem. It's suffer to the south of Afghanistan, some parts of the Pakistan, and also it affect on the navigation ships on Oman Sea. And as you see, the annual average of day with dust event in Sistan reached to 174 days. I couldn't imagine that some people living a place that with 174 dusty days. And as you see, according WHO reported in 2016, Zabul city introduced as the most polluted city from point of particle matters less than 2.5 micrometers, and as a third one from point of the pure particle matter less than 10 micrometers. And as you see, the trends of the wind energy and dusty day, the dusty day increased in the last 2 decades between 1990s to 2009, and as you see, also wind energy increased in these durations. But in the last decade, wind energy decreased, but dusty day stand at the same levels. It means that that happened on the surface in the land, and as you see, droughts, mega droughts happened at these durations in the systems. And
Dr. Abbasi, you have just 5 minutes, less than 5 minutes.
Yeah.
Thank you so much.
And as you see in the Ahwaz, wind energy decreased gradually between the 1995 and 2014. But dusty day increased gradually, and also in Abadan we have a same trend. It means that we have some problem on land. And as you see in the Khuzestans, we classify dust sources into the point source, and as you see, and also area. And I would like to focus on these dust sources. It's called Southwest Ahwaz sources. As you see, we provide of the different maps with the, for example, vegetation, soils, water resources, and morphology, and overlay all maps, and finally reach to the land sensitivity to wind erosion. And as you see, we classify each unit from land sensitivity to wind erosions, and find of the which one is a priority to fixation. And as you see, for example, this unit in the 2016 has these situations, and now after land management, we find this shape, and also in this area. Let me focus on the conclusions, and as you see, sand and dust storms are common phenomenon in arid and semi-arid area, and as WMO is as a result of the surface winds rising large quantity of the dust into the air and reduce visibility in the level of the less of the 10,000. And there are unclear trends in the SDS accuracy in Iran. Some places it increased, and some places it decreased. DSS have a negative and positive environment impact, as the Professor Op explained this one, and the activity of the dust source depend on the fraction of surface winds and local land surface properties, and key physical factor influencing wind erosion are climate factor, sediment, or soil surface characteristics, vegetation, and landforms. And as you know, STS sources can be classified into the point, linear, and area sources. Each of them needs different methods and different strategy to reduce loss. Thank you very much, Dr. Nazari, and thank you very much for audience and
thank you, Hamid, for your informative presentation. Sorry I interrupt you during the presentations, but we have to keep the time. And the next, but not least, the last presentations will be presented by Dr. Malekian. Dr. Malekian, as I said, he is a scientific member of the Faculty of Natural Resources. He has a good cooperations with national and international associations, institute, research, and university. He also was as international office affairs, the consultants and advisors of the international office affairs of the University of Tehran and advisor of the Science and Technology Park of the University of Tehran. He has several cooperations and experiences with international and national research especially about water resource management and also the effects of the droughts and climate change on water resources and its management. Arash, I would like to invite you to start your presentations for hopefully for 25 minutes. Thank you so much for keeping the time. Please.
Okay. Good afternoon, everybody. I am very glad to be here at this virtual room and happy to present about drought. And I would like to appreciate the NaDiMa project, Dr. Farzanegan and German Academic Exchange Services, they are there for organizing this valuable event. Over last presentations, Professor Oak and Mr. Abbasi talked about the sand and dust storms, and I'm going to talk about the drought management challenges and opportunities. As Dr. Nazari, whom I appreciate as well, I'm from University of Tehran and alumni member of DEAD. So I would like to ask to my colleagues in NaDiMa to show the next slide, please. Okay, if we want to talk about the drought, let's start with this complex issue. Please stop with the second slide. When I want to change, I will inform you with the change. Okay, thank you. Drought is a creeping hazard. It has a slow onset and long-term duration. It is chronic, relatively large areal extent, and it's worldwide. It's not only related to our region in the Middle East. It happens in Europe and also in other humid regions, but it's more frequent in arid and also in semi-arid regions. When we talk about the drought, we can say, please, next slide, please. Next one. Okay, definition. Below normal of precipitation is defined as the drought. And this kind of drought in terms of, let's say, meteorological drought, hydrological drought, agricultural drought happens, and what is the result? The result is that water supply that is insufficient to meet the needs of human activities and also the environment. Next one, please. And when the drought happens, usually it's associated with water scarcity, which means that water demand increases, or let's say has higher weight than water supply. So it means people, agriculture, plants, ecosystem, and environment have less water to supply their requirements. Next one, please. If we compare the drought with other natural disasters, you can see that when people talk about the natural hazards, it mostly concentrated on earthquakes. But in terms of extent and also the losses, direct and indirect losses, drought has a lot of damages, not only to the human wells, but also to the ecosystem biodiversity and also the services. Here this slide compares the drought with some other natural hazards like earthquake and blizzards. So the next one. This is the condition of the world in terms of water shortage for some years ago. And you can see that only very limited parts of the world are faced with water shortage. But what happens in the future? The next one, please. This is the projection for not very future, late future. It happens very short. It seems that many countries in the world will have water scarcity in terms of physical water scarcity, economic water scarcity, and even no water to use. And what will happen in 2025? The next one, please. Here you can see that many countries in the world even in the Europe will face with a water shortage, and mostly these countries are located in the Middle East and North Africa, which is very vulnerable to natural disasters such as droughts. The next one. In this slide, you can see the water stress in the world, and as you can see with this map, the water stress in many parts of the continents in the world is increasing, but it's most severe, as I mentioned in last start, in the Middle East and North Africa, as abbreviated as the MENA region, because of many reasons, such as climate change, that I'm going to explain in the next slides. So my presentation about the next one, about the challenges and opportunities. Let's work with some challenges that what is the reason that human is not able to fully control the drought issues. One issue is with the uncertain behavior of the drought. Why? Because the first rainless day in a spell of fine weather contributes as much as to the drought as the last day, and no one knows precisely how serious it will be until the last dry day has gone and the rains have come again. So it makes it difficult, not only in developing countries, but also in the developed countries, to precisely predict the drought and also other extreme events like the floods. So the next one. And the other problem is that sometimes we think about the natural hazards in political borders, but issues like drought knows no country borders. So what we can do? We should work on regional scales, and it's not sufficient to think about the drought in just a geographical or political border, and it's very important in collaborative issues in drought management. The next one of the challenges that is increasing the drought issue, as also emphasized and mentioned in last presentation by Mr. Abbasi, is greenhouse effect and global warming. And as you can see, there is an increasing trend of temperature in the world. It means that the temperature, according to the several scenarios, has increased and also will increase in the future. So it makes it difficult to manage water resources in a manner to support and to meet all the needs of human and also the environment. And if you see the next slide, please, which shows the emission scenarios and temperature increase, it shows that according to the latest scenarios, let's say the RCP scenarios, we will have 20% likelihood of exceeding 4 degrees Celsius at the end of this century. And also we have 50% chance of temperature rise above 3 degrees Celsius by the last year of this century. So please consider that this is average values. In arid and semi-arid regions, it may be higher. So it increases the water resources problems. Not only the water resources problems, desertification problems. And not only desertification problems, fire problems. Over last months, we had severe fire problem in Australia. Also in these days, there is a huge fire damage in the western United States because of the fire. So global warming, and also as you can see in the right hand side, over last years we had some extreme records of temperature of all recorded data about the climatic condition of the world. So you can see that we had the warmest years on record in 2015 and 2016. And also we had such cases in 2018 with highest records because of extreme weather condition. And this extreme weather condition, one of the reasons is the climate change impact. So this climate change impact accelerates some extreme events and also patterns such as drought. Just to mention that drought is not a new phenomenon. Drought is in the history. Even if you back to our historic documents from 2,000, 3,000 years ago, it has mentioned the droughts. So it means arid and semi-arid regions like Iran have already recognized and live with drought. But over last years, this increasing temperature has increased the vulnerability of the region to extreme events such as droughts and also floods. So in some cases, even we can see that in 1 year, we have in one part of the country drought, and also at the same time in other part of the country severe floods, as happened 2 years ago. And I'm glad that Dr. Farzanegan is planning for another meeting on flood, so we will be able to talk more about the other side of the coin, which means excess water and flood issues. Please, next slide. Here is the projected future precipitation. You can see the condition of future precipitation over the world, and one of these vulnerabilities is in the, as I mentioned, in the Middle East and North African region, which is maybe 20% decrease in precipitation. And it is just to remind you that it is not only with the amount of precipitation. Sometimes the pattern of precipitation is changing, and sometimes the ratio of snow to rainfall is changing. All of these issues affects the region and increases the vulnerability to other natural disasters like desertification, as mentioned by Professor Ob and also Dr. Abbasi in their presentations. The next one, please. When there is increased precipitation and, let's say, at the same time increased temperature and decreased precipitation, so it's very obvious that the drought conditions happens. It usually starts with meteorological droughts and continues with the surface flow, also groundwater flow, also the agriculture, and what happens at the end, land degradation, which is very dominant in arid and semi-arid regions of the world, let's say, such as our country. And this is one of the problems that drought issues. Also, it increases fires on forests and also on rangelands. And next one. I mentioned that climate change has altered the precipitation, but not only the amount of precipitation, but this normalization of the phenomena has changed. And if you see here, according to one of the latest research, half of the annual precipitation in the global scale has occurred just in 12 days of the year. It means that the pattern of precipitation has changed. In some small parts of the year, we have heavy precipitations, and the other parts and the remaining parts of the year, nothing happens. So it means no water for ecosystem, no water for plants, and no water for environment. Also no water for some people. And it forces people for immigration from rural areas, from nomadic areas, to the big cities. And this is one of the socio-economic challenges of the drought, which is caused by climate change. Climate change has affected extreme events such as droughts, such as floods, and it's causing problem. Unfortunately, it's increasing. The next one, please. Here is the precipitation distribution of our country. If you consider this as a long-term normal, you can see that about 60% of precipitation of the country is only, let's say, less than 250 millimeters per year. And this is the long-term record. Imagine that this distribution even will change in the future because of the effects of climate change. It means that we will have more drier regions, and at the same time some days with the flooding events. And this uneven distribution of precipitation is also in space, and not only in space, in time. And the climate change is changing spatial and temporal pattern of precipitation, not only in our country, but also in all parts of the world. The next one, please. Here is I would like to mention to this just as a hot extremes. You can see that with the increasing global mean warming of temperature, the probability of hot extremes is increasing. And as I already mentioned, all of these facts are on global scale. And in arid and semi-arid regions, this probabilities is higher. So it means we are more vulnerable to these extreme events such as hot spots. The next one, please. Here compares the global and West Asia records. So about what? It is annual maximum daytime temperature, it is annual 5-day maximum temperature, precipitation, and also consecutive dry days as a function of global warming. All of these three indices in West Asia, consider the upper side of the figures, is much more higher than the global scale. So it means our region as part of West Asia is much more susceptible to natural extremes such as droughts and also maybe to flooding. The next one. So drought is affecting and also has affected a lot of human lives, not only in Iran, but also in neighboring countries, in West Asia, in India, in Pakistan. So it needs regional collaboration in drought management. In our country, like many other parts of the world, many rivers have been dried or their discharge has decreased, and many rural populations were affected. And the research shows that in near future, let's say about 50 countries will face water stress, and most of these countries, interestingly, are located in West Asia, North Africa, and Sub-Saharan Africa, which is very important and needs more collaborative agreements and discussions about how to manage collaboratively these common challenge in the near future, which affects many parts, let's say economic water scarcity. Next one, please. This slide summarizes the effect of water scarcity, which comes from problems like drought on industry, on households and people, how to use water, limited water, on the economic policies, regulations, on the environment. Let's say e-flows are one of the challenges and important issues, and not only the water scarcity is a primary problem, but it increases other problems like fire, like desertification, and also land degradation. So what can we do with this? The next one, please. Some countries are working on monitoring networks. A lot of work have done in Iran on drought understanding, on drought management, and also adaptation to extreme events. And if you see the literature, there are very nice results of these works that have been published in the multi-sectoral approach about drought management. But as I mentioned, this needs regional networks. I have mentioned to Drought SPIR, which is a pan-European drought network, and in the region, in the Middle East region, we need such drought networks for why? To identify the gaps in regional scale for addressing and responding and recovery to drought. And also we need to coordinate planning, monitoring, and evaluation of drought. As many people in this room know, and also Mr. Abbasi mentioned, some of these droughts are causing dust storms, and these dust storms comes from our neighboring countries, and the origin of this dust storm is not inside the country. So the drought causes dryness of wetlands, and it causes dust storm, and it's difficult to choose one problem and ignore the other issues for risk management. Next one, please. A regional framework to better understand and collaborate for drought risk management is necessary. And our country has also emphasis on the need for improved preparedness for drought consequences, which is reinforced by the vulnerability of the region, and regional drought alert information network, like some other parts of the world, is necessary for changing, the next one please, for changing the risk management with the crisis management, because some of the parts of this risk management comes from natural events, sometimes are not avoidable, but some parts comes from social factors, from vulnerability, which are totally avoidable, and we can work on this part to reduce the vulnerability, not only in a watershed, let's say, a river basin scale, but also in the regional scale. And to reach this, we need the intelligent drought management system. Let's say drought is complex and intelligent phenomena, and to encounter, or let's say to combat with this intelligent drought, we need an intelligent management. And here I'm showing that some knowledge-based decisions for drought management, which comes from the intelligence and expert of the people, and it backs to history. We have drought from many years ago, and Iranians, this is Kanat, or let's say Karis, or different names, which is the very good system to adapt with drought, water scarcity, and climate change, which comes from 1,000 years ago. This kind of indigenous knowledge, which comes from the intelligent human, in addition to other solutions, may overcome the drought and water scarcity. Also, some other examples that how we can work with this drought is ecosystem-based adaptations. There are different measures that we can work with the green options, green-gray options, and also green-brown options, in addition to political and social options, to overcome the drought by a coherent strategy for adaptation and risk management. And also, finally, we need the climate risk informed decision analysis to define the future projections, to understand the trends and sensitivity, and establish the confidence range in order to have the alternative plans and to evaluate them to select the best one and to make decisions in this complex issue. And at the end, I hope that I will be on time. Thank you very much for your time. Again, I appreciate the organizers of this virtual meeting room, Dr. Farzanegan, Dr. Nazari, and also my appreciations to Professor Ope, Dr. Abbasi, University of Marburg, and I deeply appreciate all patient participants of this virtual meeting. Thank you very much. Vielen Dank.
Thank you so much, Arash, for complete and nice presentations. And also here I should like to thank the NaDiMa projects, because they are behind these sessions, and they do a lot of fairs also for questions and remarks. We are behind of the time schedule, but we have several different questions with different themes from all presenters. I have sent the questions for the presenters, and I try to compile some of them for time, lack of time, but I know that we have discussed several hours or days or several sessions about these disasters, about different aspects such as economic, socio-economic, about the rights, and also the technicals and socio-economics. But the time is limited, and I'm so sorry for that we cannot cover all the issues here in this virtual sessions. Let's start by some technical questions from Professor Ope that some participants ask about the chemical compositions of the dust, and also about the different terms about the depositions rates, and about the economics effects, Professor Ope, and also about the uncertainty in desertifications, the problems, that of course these are very, the compile or sometimes complicated issue. Thank you.
Yeah, thank you very much for the questions. So the first point was the chemical composition of the dust. I did not spoke about it, and I have no prepared now slides about the chemical composition. However, we have analyzed the chemical composition in our study areas in Central Asia, and what we have found was a very clear enrichment of those dust samples enriched by hydrogen carbonate, by sulfates, by calcite, which we could identify as directly, more or less directly, sources coming from the dry bottom of the Aral Sea. In other cases, in other stations where we have undertaken this analysis, we could find also some other elemental compositions which we not could connect it to the source of the Aral Sea. So because Aral Sea is the most famous source of such effects, but in Central Asia we have also a lot of small solonchaks, salt depressions, which also might be sources to this. On the other side, regarding the chemical composition, I want to inform you that there are some, how to say, thresholds or value of percentages of some chemicals or compositions in the dust. And so the chemical composition of the dust can also function as a so-called fingerprint of the origin. So if you will investigate deposited dust continuously in very short time sequences, you can relatively good identify the source. But I must also say, in most of the cases, we sample dust and sand samples as a summary of a monthly sample. And during 1 month, dust from different sources and different directions we have sampled. This is not so easy to distinguish which part of the composition comes from which side. This is not so easy. Relatively easy is to identify if you have at the same time the satellite monitoring system, and you, in most of the cases, you can identify heavy dust storms by satellite images. You cannot identify normal, very small dust storms, but heavy dust storms you can relatively good identify with the help of satellite images, for instance, the MODIS satellites. And therefore, when you even sample during such special event of a heavy dust storm, the sample, then of course it's relatively easy to connect the chemical composition with the sources. And of course, one prerequisite is also the knowledge of the geological basement, the knowledge of the soils which occur on potential sources. So this is regarding the chemicals. Then another question was about concrete amounts. I did not include concrete dust amounts in my presentation because I thought for most of the people it would not be so interesting to listen how much gram per square kilometer or gram per cubic meter we have sampled. But I will give you some examples to have an imagination about what amount of dust we speak. So, for instance, if, again, I come back to very heavy dust storms, we have studied such heavy dust storm in Kazakhstan with the help of our Kazakh colleague. This dust storm operates approximately 36 hours. And the Kazakh colleagues were on site measuring the deposited dust of this heavy dust storm. And they have measured approximately 60 grams of dust in the time of 36 hours. This was our very large amount of dust, what we have measured. Another so-called, what I say, normal amount of dust, these are only 1 or 2 grams per month. This when you listen 1 or 2 grams per month, this seems to be very low. But during 12 months, it can be more and more. And this is, when I spoke 1 or 2 grams per month, this is without heavy dust storms. This is just the normal deposition. So plus heavy dust storms, you can get a lot. And so you can understand this also can change the chemical balance. So the chemical compositions on site, where it comes from, and on site, where it will be deposited. So there are a lot of the amplitude of dust amounts per month or per year is quite different. To tell you also one example from the Aral Sea study area, for instance, in the near to the Aral Sea lake, we have sampled approximately 120, 130 kilogram per hectare per month. So these are also single numbers now, but to have an imagination about which numbers we have. All the other numbers I have in tables, but not here present. Then another very important question, and I'm sure we come back to this question more and more, is the, from my point of view, unloosed question of the international problem of sand and dust storms. Because most of the sources are outside of the country. Also Iran has a lot of inside sources, but anyhow we know from our investigations with the help of Mohammad Reza Abbasi, with the help of Mansour Foroshani, that Iran also get a lot of dusts from outside. Even in the southwest Khuzestan you get a lot of dust from Iraq, from Syria, but also from Saudi Arabia. And with the help of satellite images, we also know that also Saharan dust will be or is deposited in Iran. And this is a special problem of science at the one side, with the help of satellite images, with the help of a so-called LiDAR system, it is possible to observe the international origin of large dust flows, not of small, but of large dust flows. This is possible, but until now is no solution, no regulation, no agreement how to handle this international problem. In most of the cases where dust from other sources from outside is deposited, this is a negative effect. But in some cases, I gave you such example in my presentation, the farmers in Latin America, in the tropical Latin America, are very lucky about that they get Saharan dust with a rich elemental composition to fertilize their poor tropical soils. So this question, from my point of view, is no solution. The UNEP has some impulses, but at the moment, as I know, there's no solution, and there's a lot to do as scientific basic investigations, but of course at the end is also a kind of scientific political work to do. I do not understand now.
You know that there is as I said, variety of questions with different subjects, but you could cover them. But if the participants need to more illustrations and or discussions, just please be patient and let's that to all of the answers, all of the questions would be answered maybe in the coming answers from the other presenters. They could find their questions. And the next questions from Dr. Abbasi. The presenters would like to know several points. The first, they would like to know about the regional cooperations to reduce the cost of the sand and dust storms. I think that these questions wants to know about the regional agreements, or as the Professor Ope said, about the effects of the other countries or other lands on dust emissions and coming into the regions, but actually these regions is a receptors, and while as a sink, not source, and so how we can increase the regional cooperation. The other things, it's about the policies. What is the policies you suggest to cover, to deal with sand and dust storm in Sistan and Khuzestan? Are the drivers and causes in these regions are same or differences? Thank you, Hamid.
Yeah. Also, thank you very much for the question. First, focus on regional cooperations. I'm not politician, and I'm
Thank you, Hamid.
Policy makers. It's returned to the Iranian government, and as you know, the professor mentioned that we can classify dust sources which affected Iran into the external and internal sources. But I should know that internal sources affect very severity on our land. For example, when southwest Ahwaz sources will be active, very severity dust affected in the Ahwaz city. But when it comes from other countries, for example, from Syria and Iraq and also Saudi Arabia, it is not very severity, and it's possible to pass. And for example, Khuzestanian people told me when Ahwaz, southwest Ahwaz sources create of the emissions dust into the atmosphere, they say it is not dust, it is devil dust. I don't know, it's how can to say? It's a very high density high density, and another questions for policy. Yes, for example, in systems, we should be change all decisions. Right now, we focus on the develop agriculture, but I prefer to focus on the wind energy harvest. For example, we shouldn't develop agricultural university and agriculture schools in systems. We should develop of the wind energy harvest university in system, and when use of water for agriculture, it is wrong way. You know, for example, we should find another solutions. We couldn't doesn't attention to the wetland or Hamun lakes, and just for develop agriculture, and then want to control dust. It is not possible. You know, the Hamun lakes cover 500,000 hectares, 500,000 hectares in, and we couldn't find of covered by vegetations or plantations and other methods of the control for physical and chemical, for example, mulch and other methods. We just focus to change in strategy, and change of the income of the peoples. According now, most of Zabolian focus on the just agriculture, and but it is not possible to continue this method. Yeah. And for Khuzestan, but for Khuzestan, I think we should we should focus on the land use planning because the kind of the sources is an area, and we have as you know, three very famous rivers, Karkhe, Karun, and Zohre, irrigated of the Khuzestan's plain. And we have a water, just Karkhe river irrigated 6.2 milliard cubic in this year, and we could change of the, we could attend to the cultivated agriculture and also irrigated land, but also should be attend on the lowlands and some ephemeral lake which called Hurs, for example, Hurul Hoveyze and other ephemeral lake in Khuzestan, and also rehabilitations of the vegetation. As now we have a plantation, some tree, and it was a very successful. As I show some slide. Yeah.
Thank you, Hamid. The last point is about that one of the participants asked about, is there any international regulations or agreements about intra-boundary dust storm? As much as I know, because I'm as a member of Committee of Science and Technology of United Nations Convention to combat desertification, I cooperate, of course, not as a member, cooperate with this committee, CST. This is the only regulations, international regulations about land degradation related to UNCCD, United Nations Convention to Combat Desertifications. It is under UN, and more than 193 countries accepted these conventions. But this convention can act as a focal point, I think, in the Middle East to get together all the countries around the table for negotiations for this. For example, in some countries, because of developing of a large mega dams, for developing, for example, in Turkey, north of the Iraq, and construction of dams on the large river, Tigris and Euphrates, caused that over the past decade, the large date forests in urban routes have been dried because of the construction. But these are the complicated issues, and you know that in Middle East, North Africa, because of the different countries, different nations, and so it needs I think that an international organization such as United Nations can gather the countries around the tables and start a point that the hazards from, for example, the dust received in Iran are coming from the outside, and so the countries should negotiate for these issues. And the last questions, Dr. Malekian, that the participants would like to know about the economic, the effects of, that maybe the sanctions and economic sanctions on ability of Iran to manage droughts or sand or dust storm problems, or how it's possible to incentive, to estimate the private sectors to get together or capacity building to manage the natural hazards? And two other questions, Arash.
Actually, I'm not expert in dust and sandstorms. Maybe other colleagues can explain much more better with the economics of sand and dust storms. But in terms of drought, I can say that drought caused by issues like climate change has direct and also indirect impact on the economics, and different parts of ecosystem as well as human life are affected by drought issues. That will be increased in the future, and it means that in the future we will have more extreme climatic events and also more economic losses. And it's not just in one country. If you follow the news, every part of the world these days are encountered with these natural hazards, from the European continents, in Australia, in the US, also in the Middle East. Many parts of the world are encountered with the water scarcity and also hot extremes. These extreme events, climatic events, have a lot of economic losses, and as far as I know, some United Nations organizations have reports on the economic losses. For example, if you see the recent reports released by APTIM-SCOP, one of the branches of the United Nations, they have calculated the economic losses for example, for flood management. I have also seen one report about the dust storm, but I am not very skillful in dust works. Maybe other colleagues can answer more precisely about the dust events economics. Thank you very much.
Your microphone is off, Dr. Nazari.
Last questions asked by participants is about the long-term and short-term climate change effect on desertification in Iran. What's your idea about these two, long-term and short-term? Dr. Malekian, can you hear me? Thank you, Arash.
Desertification. Actually, I don't have any idea about desertification. Maybe Dr. Abbasi can talk about desertification. But if you mean, or if somebody who has asked the question about the long-term or short-term effects of climate change on drought, I should mention that climate change usually works on long-term. So in short-term, it's difficult to calculate this kind of economic losses. But if you consider longer periods, it will be more meaningful to calculate the effects of climate change on drought and water scarcity, and on desertification. Maybe other colleagues can have better answers. Thank you.
Maybe the issue asked here is about the effect of the economic sanctions on the and its effects on the ability of Iran to manage the drought or sand and dust storms, you know that this is really not very clear, but as much that I can address it, you know that most of the projects in Iran are controlled, or most of the projects about the sand and dust storm management or droughts are under the controlled by the government sectors, because you know that natural resources in Iran are a commonwealth. So the government are responsible for combating the sand and dust storm in one side. But on the other side, in private sectors, for example, by dust and emissions and, for example, the disease and the side effects, indirect effects, are on the load of the peoples, of the society. Actually, it's difficult to say how much it depends on the governments or private sectors, but definitely it's affected because, as I said, the governments are the main foundations, resources for the combating sand and dust storm. So by decreasing the foundations of the government, it would be affected. The other side related to the insurance company that they are responsible for the droughts. They are trying to cover this. Hopefully, until now, the insurance companies in Iran could cover the droughts, especially in agricultural sections, the effects of the drought. They cover the drought, and by these two supports the rural people. I think that as much as I check, the questions have been covered. You know that as a conclusion for this point, again I would like to thank our DAAD and Dr. Farzanegan and his colleagues and NaDiMa projects for organizing these virtual and sessions, and a lot of points about dust and sandstorm and droughts discussed here about the principles of dust storm and sandstorm and its effects. Also, in these sessions, we could cover that dust storm and sandstorm is not only affected the dry lands, but they could affect a large area far from the source area, so it cannot be just a problem for the on-site societies, but other off-site societies that they are far from kilometers from the source area are affected, so we need a common knowledge. We need, I think that the researchers, one of the duty for the researchers is to discuss from different resources to find a common knowledge about how they can find the solutions to decrease the effects of disasters. And okay, I checked, to check all the other questions. As much as I know, the questions have been covered. At the end of these sessions, I would like to have the other feedbacks from the participants or presenters and Dr. Farzanegan. Dr. Farzanegan, the session is yours.
Yeah. Thank you very much, Dr. Nazari, and all other speakers, Professor Ob, Malekian, Professor Malekian, and Dr. Abbasi, for great discussions, also from all audience who joined with us in this third event of NaDiMa and stayed with us somehow longer as it was planned. It was an important debate which needs, of course, more elaboration in future, the topic of drought and the sand and dust crisis, which especially is affecting specific provinces in Iran, but Iran is not the only example which is getting affected by this problem in the region. And we hope that this academic collaboration between Germany and Iran helps to somehow at least offer opportunities for training human capital which is needed to deal with these climate problems. And here it is the role that we are playing more or less at this specific level to help and to stimulate this academic exchange and collaboration. And this is the purpose of our project. And we hope, of course, part of this reflection be visible in the policy making process. So, and this is our effort here. I thank you everybody here for listening and joining the discussion and many questions, and also the presenters who kindly accepted our invitation to come and join and offer their inputs here and contributions. The next webinar is planned for the end of October on the topic of flood management, more precise data on the date and the time, and speakers will be published on the NaDiMa website at the University of Marburg. The presentations and the recorded file of today's event will be also be available in the coming days in the website of project, so you can also look at the presentations and listen to the recorded material here. So this is from my side. If my colleagues would like to add something, Herop or Professor Malekian, Abbasi, please.
Yeah, thank you very much for the meeting. I already wrote it in the chat. So Professor Malekian has, from my point of view, given a lot of impulses to drought studies. And you know who is in Germany, that in some parts of Germany we have also strong droughts during the last years. And so I see it as a very important tool to cooperate with Iranian in this field, because you have quite experiences in drought defense.
Okay.
I also
thank you very much.
Again, thank you for your coming, and from you, Professor Ob, Dr. Malekian, Dr. Abbasi, and for patience of the participants. And in Iran, we have a proverb: "Don't be tired, khasta nabashid." Thank you so much.
I have one comment.
I support.
I have one point. Okay, just to introduce this information reference, I'm not sure if you fully can see this or not. This is available online and you can download this. You can find a lot of information about the disaster riskscape across the Asia and Pacific, published by the United Nations. And I will send the link of this report to Dr. Farzanegan. Lots of information on the country scales, and this is recently published by the United Nations. Very useful reference for all of us. Just to mention this, and also I would like to appreciate the organizers of this meeting, Dr. Farzanegan, Professor of University of Marburg, Dr. Nazari, and all participants who were at this virtual room to have this meeting in the best manner. Thank you very much. I appreciate you.
That's your kind. Thank you.
You're welcome. So let's conclude and say goodbye and خسته نباشید to all of you for joining our event today. Hope to see you again in near future, in future events of NaDiMa Dialogue.
Thank you very much.
Bye bye.